Hello algebra students and welcome to your first notes video. Today's lesson is on solving simple equations. We are going to look at how you can use simple equations to solve real life problems. The learning target is I can solve linear equations using addition, subtraction, multiplication, and division. There's some important vocab to go along with today's lesson. First off, an equation is a statement that two expressions are equal. An equation is going to have an equal sign. Next, a linear equation is an equation that can be written in the form ax plus b equals 0. So notice there are no exponents. It is just multiplication, division, subtraction, addition. All right, next, inverse operations are two operations that undo each other. Inverse operations are like addition and subtraction. Those are inverses of each other. And multiplication and division are inverse operations. And last, equivalent equations are equations that have the same solutions. And to follow along with the notes today, you can either write these in your notebook or you can download the PDF file off of Canvas and just highlight and write what I write and follow along. All right, we have 4 core concepts in today's lesson. The first one is the addition property of equality. This basically says that adding the same number to each side of an equation produces an equivalent equation. So you have to balance the equation. If you're going to add a number to one side, you have to add it to the other side. For example, you have 3 equals 3. Well, if I'm going to add 2 to one side, I have to add 2 to the other side to keep it equal. All right, same idea with subtraction. The subtraction property of equality says that subtracting the same number from each side produces an equivalent equation. Just like the last example, if I have 3 equals 3, if I'm going to subtract 1 from one side, I have to subtract 1 from the other side as well to keep it equal. Next, we have the multiplication property of equality. This says that multiplying each side of an equation by the same non-zero number produces an equivalent equation. For example, if I have 4 equals 4, and I'm going to multiply 4 by 2, I have to multiply the other side by 2 as well. And last core concept is the division property of equality. Dividing each side of an equation by the same non-zero number produces an equivalent equation. If I have 10 equals 10, that should be an equal sign. And I want to divide one side by 5, I have to divide the other side by 5 as well to keep it equal. In example 1, I want to solve the equation. When we solve an equation, we get the variable by itself. So the variable in this example is y. To solve for y, I need to get y by itself. So I look at the side that y is on. Right now, it's y plus 2.8. So I have negative 0.9 equals y plus 2.8. To get y by itself, I'm going to subtract 2.8. Because I subtracted 2.8 from one side, I also have to subtract it from the other side. So now I have negative 0.9 minus 2.8 equals y. That positive 2.8 and negative 2.8, they're going to cancel out. So negative 0.9 minus 2.8, that's going to be further away from 0. It's going to go more negative. So I have negative 3.7 equals y. And we're going to check our answer. So if I plug in negative 3.7 for y, negative 3.7 plus 2.8, if you were to enter that onto a calculator, you could double check it, and yes, that is equal to negative 0.9. Check, we're good. All right, example 2 asks us to solve the equation again. This time our variable is n. To get n by itself, I have to get rid of that negative and divide it by 5. To undo the division, I'm going to use the inverse operation, which is multiplication. So to get rid of that divided by 5, I want to multiply this side by negative 5. Because I multiplied that side by negative 5, I also have to multiply this side by negative 5. That's a times -5. All right, so when I multiply the left side by -5, this is going to cancel out, and I'm left with just n. And then on the right side, I have -3 times -5, which is positive 15. A negative times a negative is a positive. So I have n equals 15. We should always check our answer. So if I plug in 15 for n, I have -15 divided by 5 equals -3, which is true. So check, we're good. And in example 3, we have some problem solving. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So I want to know the number of meters per 1 second. So we're going to set up a proportion, which is something you learned in hopefully 7th grade. So when I set up my proportion, I'm going to have the meters on top. So I have 200 meters in 19.32 seconds. Yes, you're not supposed to have decimals in a fraction, but this is a division operation, so it's okay. So I have my meters over seconds equals, we're solving for the number of meters per 1 second. All right, so now I'm going to do that division operation, and 200 divided by 19.32 is 10.35. So then I have 10.35 equals m. What is his average speed? It is 10 and 35 hundredths meters per second. Last example for today's notes, some more problem solving. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to -4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? We're going to draw a picture and then write an equation to represent the temperature change. Okay, before I draw my picture, there is a lot of numbers in this problem. So I want to look at what I'm solving for. I'm solving for the degrees that the temperature fell. So then I need to decide what's the important information. It doesn't say like per hour or per minute. We don't need to know the time here. So the time numbers are not important. That also means that the date is not important. So the numbers I'm looking at are 54 and -4. My picture to help us out, I'm going to draw a little thermometer here. And 54 would be up here because it's positive. 0 is going to be somewhere near the bottom, but not all the way at the bottom, because we still want -4 past 0. So I want to know how many degrees did it fall to get from positive 54 to -4. All right, so now I'm going to write an equation to represent this. So I have 54 plus t equals -4. In other words, how many degrees were added to 54 to make it -4. So to solve for t, to undo the addition, we need to subtract 54 from both sides, and it's going to cancel out on the left. Then I'm left with t equals -4 minus 54, so it's going to go further from 0. That is -60. T equals -60. And so how many degrees did the temperature fall? The temperature fell 60 degrees. You could also set this up as 54 minus t equals -4, in which case t would be positive 60. So why did I set this up two ways? Because the temperature dropped 60 degrees and the change was -60. So it depends on the way you're phrasing it, of whether or not you're going to say that negative. All right, and some summary questions for you. How can you use simple equations to solve real-life problems? Well, we just saw two examples. We saw speed and distance, and then we also saw temperature. So when you solve equations, why is it important to understand how to use inverse operations? Let's think back to the first slide where the vocab was. Inverse operations are operations that undo each other. So this is going to be addition and subtraction and multiplication and division. Why is it important to know how to use those? Because that's how we're going to solve equations. We need to know what operation is the inverse so that we can undo them and get the variables by themselves. So describe in words how you would solve the equation n plus 3 equals -7. Well, we would subtract 3 from both sides, and we would get n equals -10. And then why is it important to check your solution when solving an equation? It's easy to make simple mistakes, especially when we get to more complicated algebra. So say I saw that 3 and that 7, and I thought, it might be 4 because I know 4 plus 3 is 7. Well, then when I plug in 4 plus 3, I'm going to see that, oh, that's not -7. So I need to check my work to make sure I didn't make silly mistakes like that. All right, thanks for tuning into the notes today. And make sure you check Canvas to see if there's an assignment to go along with the notes.